Hurricane Milton is not just another storm. It's being described as the worst hurricane to hit Florida in a century, with winds topping 175 miles per hour, a rapidly intensifying storm surge, and a path that could devastate millions. This storm is set to make history. But why is Hurricane Milton so powerful? What makes it so dangerous? And how did it become such a massive threat so quickly? In today's video, we'll take a deep dive into the science behind Hurricane Milton, what causes the most destructive hurricanes, and why storms like this are becoming stronger. We'll also look at what could happen after the storm passes. Let's break it down. So, how does a storm like Hurricane Milton even form? It all starts with the warm waters of the Gulf of Mexico. This year, ocean temperatures were about 3 to 5 degrees Fahrenheit higher than normal, 88 degrees Fahrenheit to be precise. These unusually high temperatures act as rocket fuel for hurricanes, causing water to evaporate into the atmosphere at a rapid pace. As this warm, moist air rises, it creates a low-pressure system that pulls in more air from surrounding areas. The Earth's rotation causes this system to spin, forming a cyclone. But that's just the beginning. To maintain and strengthen, hurricanes rely on three critical factors, which are warm water, low wind shear, and high atmospheric moisture, all of which were present in spades for Milton. Milton's rapid intensification is particularly alarming. A storm is said to rapidly intensify if its wind speeds increase by 35 miles per hour within 24 hours. But Milton blew past that benchmark, increasing its winds by 90 miles per hour in just one day, making it one of the fastest intensifications ever recorded. This put Milton from a Category 1 to a Category 5 monster in alarming under 24 hours. Why did this happen? A combination of record warm waters, high humidity, and favorable wind patterns, all supercharged by climate change. Climate scientists are seeing hurricanes' intensification much faster and become more dangerous as the planet heats up, turning what used to be rare events into increasingly common occurrences. Meteorologists saw something shocking when Hurricane Milton developed. It wasn't just how fast the storm intensified, but where it was headed, directly towards Florida, a state that had already been battered by Hurricane Helen just 2 weeks prior. But Milton isn't your typical storm. This is one of the strongest hurricanes to hit the Gulf in over 20 years. What makes Hurricane Milton particularly terrifying is the storm surge. A storm surge is the rapid rise of seawater levels pushed toward the coast by the storm's strong winds. The National Hurricane Center has predicted surges as high as 15 feet in some areas. That's enough to completely submerge homes and sweep away cars. Why is this so deadly? A storm surge isn't just water rising, but it's a wall of water with incredible force behind it. A single cubic meter of water weighs over 2,000 pounds, so when it's rushing toward land, it hits with the power of a bulldozer. Even if the hurricane weakens before making landfall, the storm surge can still cause devastating flooding. In addition to the surge, Florida is also dealing with another deadly element: the debris from Hurricane Helen 2 weeks ago. With cleanup still underway, scattered debris from homes and buildings can turn into deadly projectiles when Milton's winds pick up. This combination of powerful winds, storm surge, and flying debris makes Milton an extraordinarily dangerous storm. Hurricane Milton is a textbook example of the most dangerous hurricanes that meteorologists dread. It's a storm that is impossible to fully predict due to the sheer complexity of atmospheric forces at play. Meteorologists track hurricanes using satellite data and complex weather models, but even with all of today's advanced technology, storms like Milton can change rapidly. A storm's path can be altered by wind patterns or temperature fluctuations in the upper atmosphere. In Milton's case, a lack of wind shear allowed it to grow much stronger than expected. But it's not just about wind and water. Another critical factor is the air pressure inside the storm. Milton's pressure dropped a staggering 15 millibars in 10 hours, a clear sign that it was undergoing explosive intensification. This caused one meteorologist to break down in tears while reporting on the storm, knowing full well what that drop in pressure meant for the people in its path. We often think that the worst hurricanes are caused by heat alone, but there's more to the story. While warm water is critical for hurricane development, other factors such as atmospheric moisture and wind patterns also play key roles. Hurricane Milton, for example, had unusually high humidity levels, around 68%, combined with low wind shear. Normally, wind shear would disrupt a hurricane's formation by pushing it off balance. But with low wind shear, Milton was able to maintain its structure and continue growing. Then there's the issue of climate change. Warmer oceans mean more fuel for storms, and as sea levels rise, the damage caused by storm surges will only get worse. In fact, studies show that major hurricanes, those classified as Category 4 or 5, are becoming more frequent, and their destructive potential is increasing. We're not just seeing more storms, we're seeing stronger and more unpredictable ones. And Milton is the latest terrifying example of this trend. Hurricane Milton started as a tropical depression, but its path across the warm Gulf of Mexico gave it everything it needed to grow into a monster storm. Currently, it's projected to make landfall near Tampa, Florida, home to over 7 million people. Authorities have issued evacuation orders for entire counties, urging residents to seek shelter or leave the state entirely. Milton's slow movement, about 12 to 13 kilometers per hour, means that it has had plenty of time to gather strength, and it's dragging an immense amount of water along with it. Florida's emergency teams are preparing for what could be catastrophic flooding across large parts of the state. With up to 18 inches of rain expected, flooding isn't just a coastal concern. It will affect inland areas as well. When Hurricane Milton finally passes, the real work begins. The damage from the winds and the storm surge will be immense, but the long-term effects could be even worse. Power outages are expected to last for weeks, leaving millions without electricity. Roads will be impassable and cleanup efforts could take months. The economic impact is projected to be in the billions, and for many Floridians, life will never be the same. Hurricane Milton isn't just another storm, it's a reminder of the growing power and unpredictability of our planet's climate. As the oceans warm, we're likely to see more storms like this in the future. So, what can we do? Stay informed, prepare early, and most importantly, heed the warnings. Thank you for watching. If you found this video informative, make sure to hit the subscribe button and click the notification bell so you don't miss any updates on Hurricane Milton or other extreme weather events. Stay safe, everyone.